Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying Trigonometry Lecture 5. This is our QD8. Take the screenshot. Let us start with the transformation formulae. Now this is one of the most important topic in trigonometry because you'll be utilizing these formulas many times. So it's not like that these formulas are very new to us. We have already done sine of a plus b, sine of a minus b. We just have to utilize them to bring in some new formulas, basically to convert summation to multiplication or from multiplication to summation back, right? So let's look at this one first. So the derivation is very easy. So basically you'll have to just expand it. So sine of a plus b is nothing but sine a cos b plus cos a sine b. And similarly, sine of a minus b is sine a cos b minus cos a sine b. Now, when you add both of these, this gets cancelled out. So we get 2 sine a cos b. Now, the trick over here is you won't get this kind of formula in this format, right? You'll get something of this sort and you'll have to convert it back to this formula. So that's how tricky it is. So basically, you won't be getting sine of a plus b sine of x1 plus x2 plus sine of x1 minus x2. You won't be getting this. Now the second formula is also very intuitive. You just had to subtract these formulas and you'll get this formula. You have to remember this formula. Now let's look at this one, cos of a plus b plus cos of a minus b. Now we know that cos of a plus b is cos a cos b minus sine a sine b. And similarly cos of a minus b is cos a cos b plus sine a sine b. So on adding both of these, you'll get 2 cos A cos B. Similarly, just like the initial one, the previous one, you'll get 2 cos A cos B format and you'll have to convert it into this format. Now this one is a little counterintuitive. Unlike these three formulas where you won't be getting any negative sign over here, in this one you will be getting a negative sign over here. Or else what you can do, you can write cos of A minus B minus cos of A plus B. You can remember in both manners. Derivation is same, you just have to expand it and you'll get the formula. Now let's look at this illustration. So this was the thing I was talking about. So basically you'll be getting in multiplication form and you'll have to convert it back into the summation form. So now let's solve it. For that I'll have to multiply and divide by 2. So basically I'm taking 1 by 2 as common and writing 2 over here. 2 sine 21 dot cos 9 minus 2 cos 84 dot cos 6. So this is 1 by 2. That is 2 sine a cos b. So basically sine of a plus b plus sine of a minus b. So it will be sine of a plus b, that is 30, plus sine of a minus b, that is sine 12. Now this might be looking worrisome, but because since we are having one more term over here, we can see what can be done. Minus 2 cos a cos b, that would be cos of a plus b. This is 6. That would give me cos of 90 degree plus cos of a minus b. That would give me cos 78 degree. Now we know that cos of 78 is a complementary angle. 78 is a complementary angle to 12, right? So basically cos of 78 is nothing but sine 12. So we'll be getting sine 30 over here. That is 1 by 2 minus that is 0 over here. And these two gets cancelled out. So 1 by 4 is the answer. Now the reverse side of the formula. So basically what we saw earlier is this only, but it's written in a different manner. How? Let's again write sine a plus b plus sine a minus b. That was 2 sine a cos b, right? Now what if I write a plus b equals to c and a minus b equals to d? So to transform this formula into this one, I'll do this change. A plus b equals to c, a minus b equals to d. Now if I add both of these, I'll get a as c plus d by 2 and you'll get b as c minus d by 2. When you subtract both of these, you'll get b as c minus d by 2. Now plug it in over here. You will get 2 sine c plus d by 2 dot cos of c minus d by 2. So the formulas are same. So basically, you'll have to use this kind of formula for reverse transformation, basically from multiplication to this one, and this formula from this front transformation from addition to multiplication. So you'll be using both of them, but the format is a little different. Now over here, it's also same, sin c minus sin d, that is 2 cos c plus d by 2 sin c minus d by 2. You'll again have to write in a similar manner. Similarly over here, but now this one is a little tricky. Let's see this one. So we know that cos of a minus b minus cos of a plus b, that is 2 sin a sin b, or cos of a plus b minus cos of a minus b, that would be minus 2 sin a sin b. Either ways you can write it. You can write it in this way, you can write it in this way. Let's check out this one. Let's say we are again using a plus b equals to c and a minus b equals to d, making it cos c minus cos d. Now what we'll get over here, a equals to c plus d by 2 and b equals to c minus d by 2. Now we'll be plugging over here, minus 2 sine of c plus d by 2 sine of c minus d by 2. Now use this minus sign over here, 2 sine of c plus d by 2 dot sine of d minus c by 2. Why I'm deriving these formulas? Because just in case if you forget these formulas, because sometimes it becomes confusing if it is 2 sine a sine b, 2 sine a cos b, whatever is there. So just in case you forget this formula, you can derive it with this manner. So this might confuse you, d minus c, and you might tend to forget it while applying during the examination. So that is why the derivation part. In other formulas, it's c plus d, c minus d, c plus d, c minus d, c plus d, c minus d. But over here, c plus d and d minus c over here. So just in this case, just like this one was a special case with minus sign over here. So this one is the counterpart for the same. Now let's look at this illustration. It says find the value of sec 11 dot sec 19 minus 2 times cot 71. So my first thought would be to convert this entire equation to sine and cos. In most of the cases, converting into sine cos usually works unless there is a very specific case. But in most of the cases, simplifying the equations into sine and cos mostly works because most our formulas are in that way, right? So I'll write it like 1 upon cos 11 dot cos 19 minus, I'll write it as 2 tan 19 because that would give me tan sine 19 divided by cos 19, and that looks favorable over here. So I'll write it as 2 sine 19 divided by cos 19. I'll take the LCM, I'll get 1 minus 2 sine 19 dot cos 11 divided by cos 11 dot cos 19. I also did that because I took the LCM because it looked favorable, 2 sine a cos b over here cos a cos b. So I can apply the formulas over here. Now this will give me 1 minus sine of a plus b, that would give me sine 30, minus sine of a minus b, that would give me sine 8, divided by cos 11 dot cos 19. Now what is happening over here? I can see that becomes 1 by 2 minus sine 8 dot divided by cos 11 dot cos 19. Now one can get stuck over here because there is a numerical value over here. There is some random angle over here, 8. We don't know the value of 8, right? Sine 8. And the other two angles are also not very promising. Even if we convert into the summation formula, we're not able to clearly see what kind of thought process I should have to cancel the stuff out, right? So in that case, but we definitely know that we have to apply summation or transformation formulas somewhere over here because there is no other option. So one thought that clicks my mind, I'll write 1 by 2 as sine 30 once again, because it was a positive term over here. It was a negative term over here, sine 30. 30, it was negative term over here, but now it has become sine 30 as a positive term. Now I can apply sine c minus sine d, and that might do something, right? So I'll write it as sine 30 minus sine 8 divided by cos 11 dot cos 19. Now this will give me sine c minus sine d is 2 sine c plus d by 2, sorry, 2 cos c plus d by 2. That would give me 19 dot sine c minus c minus d by 2. That would give me 11 divided by cos 11 dot cos 19. So this cancels out. So we'll get the answer as 2 tan 11. So C is our correct answer. So you are able to understand the thought process, right? How we have to apply the transformation formulas. So even if you're not able to apply, if you're not able to directly see that we have to apply transformation formulas, we'll have to convert this into a form so that we can apply transformation formulas. Otherwise, we might get stuck over here and we might have to leave the answers. It's not a very difficult question. The only difficult part over here is to think that we have to write this again sine 30. It comes out with practice, but you have to understand that if you are able to see that this is only happening with transformation formulas, then we have to apply it some way or the other. Now let's look at this one. Value of cos 2x plus cos 4x plus cos 6x minus 4 cos x cos 2x cos 3x. Now again over here I have two choices. Either I convert this summation into product, or I can convert product to summation. So as of now, this looks very easier because converting this into some constant value and into a similar kind of product might be very tricky. So the thing which suits us most is converting this into summation part. So I'll write this as separately for 4 cos x dot cos 2x dot cos 3x. Now I can clearly see that if I'm going to club these two or these two, then I'll be getting some odd values which are not there in the actual summation values, right? So I'll have to club x and 3x. So basically I'll write 2 times cos 2x dot 2 cos a cos b. So this will give me 2 cos 2x, and 2 cos a cos b means cos of a plus b. That will give me 4x plus cos of a minus b. That will give me 2x. Now again I'll club both of these. I'll get cos of a plus b plus cos of a minus b, and clubbing both of these I'll get cos of a plus b plus cos of a minus b, that is 0. Cos 0 is 1. So basically I got this entire expression which was in the left side. So basically this gets cancelled out and we get -1 as the answer. So it is always your choice what you want to prefer. If you want to convert this into product, or if you want to convert this product into summation. So basically over here it was very suitable to convert this product into summation. So we did that. Now let us start with the last topic of today's lecture, that is trigonometric series. So as far as PGDBA is concerned, this topic is not very relevant, but you still have to remember the formula. And I'm deriving the formula just for the sake of concept clarity. So let's start the derivation. So I can see that we have a sine beta by 2 over here. So I'll have to introduce sine beta by 2 somewhere or the other. Now the other thought is, whenever I have to solve this kind of series, I'll have to create a different series so that terms gets cancelled out and we get a singular term over here, just like over here, right? So for creating a different series, I cannot multiply it with the cos term, right? Because that will give me 2 sine a cos b, and that will keep on adding terms, because that will be cos a plus b plus sine a plus b plus sine a minus b, right? But in case of different series, what I'll have to do, I'll have to multiply sine a sine b. I'll have to create 2 sine a sine b, right? So I'll have to multiply a sine term over here so that I can create a different series. So that term seems to be sine beta by 2 over here. So what I'll do, I'll multiply and divide by 2 times sine beta by 2. That will give me sine alpha plus sine of alpha plus beta plus sine of alpha plus 2 beta sine of alpha plus n minus 1 beta. Right. Now let's try to club these two. So we have 2 sine beta by 2, sorry, 2 sine beta by 2 dot sine alpha. So 2 sine A sine B, that means cos of B minus A. Either I can write cos of A minus B or B minus A, both are same, because in case of cos, negative sign doesn't matter. So I'll be writing B minus A, alpha minus beta by 2, minus cos of A plus B. That will give me alpha plus beta by 2. Now the other term is 2 sine beta by 2 dot sine of alpha plus beta. So that will again give me cos of alpha plus beta minus beta by 2. That will give me cos of alpha plus beta by 2, minus cos of the summation of these two terms. That will give me alpha plus 3 beta by 2. Now the other term is sine beta by 2 dot sine of alpha plus 2 beta. So that will give me cos of alpha plus 3 beta by 2 minus cos of alpha plus 5 beta by 2. Now if I am going to multiply it with the last term, that will give me sine of alpha plus n minus 1 beta. That would be cos of this minus this. That would be alpha plus n minus 1 by 2 beta, right? Minus cos of this plus this, alpha plus n minus 1 by 2 beta, right? Oh, sorry, this one is 3, sorry, 3 by 2 beta. Now we can clearly see that these terms gets cancelled out. The only term remaining is cos of alpha minus beta by 2 minus cos of alpha plus n minus 1 by 2 beta. So let's try to solve that one too. So we'll be getting cos of alpha minus beta by 2 minus cos of alpha plus n minus 1 by 2 beta. Now this will be cos c minus cos d. Cos c minus cos d is 2 times sine of c plus d by 2. So that will give me 2 alpha and plus n minus 1 beta divided by 2 times sine of d minus c, this minus this one. So alpha gets cancelled out and we'll be left with n minus only n beta by 2, actually n beta by 2. Now we have this additional division over here, 1 by 2 times sine beta by 2. So 2 gets cancelled and you'll get the desired formula. So this is just for the understanding purpose, how you should be thinking to create a different series. So basically we didn't multiply 2 cos beta by 2 because that will be creating a addition series and not a different series. So in order to simplify this particular series into a singular term, we'll have to create a different series, and for that multiplying by 2 sine beta by 2 was the key. Now in terms of cos series, similar kind of cos series, the only difference is we have cos over here. In case of sine, we had sine over here. In case of cos, we have this cos over here. The other portion is totally same. So today's lecture was still here only, and this marks the completion of the trigonometry syllabus. We'll be adding few more lectures or videos for trigonometric functions and trigonometric equations. So, but that will be very short ones and not as detailed as these ones. So these were the main concepts which we have covered in these 5 lecture series, and that should be enough to crack the PGDBA trigonometry. So let's meet tomorrow. Thanks for watching.